ground motion data. It was especially for this study to present the actual Aqaba situation. The catalog was made available by the Jordan Seismology Observatory, which shows event less or equal than 6 with ML and above 6 as MW until the end of 2009. And now we come to the earthquake scenario definitions. 3 scenarios were used and defined based on the nature of the Aqaba city. The first scenario was to represent the Aqaba fault earthquake scenario. The second scenario was to represent Wadi Arab earthquake scenario. And the third one was to represent the Gulf of Aqaba earthquake scenario. So we chose the 3 scenarios. These scenarios reflect the major active faults that may affect Aqaba city with maximum moment magnitude of 7.5 for all scenarios. The motion of the faults of these scenarios are strike slip, as I said before, in major components and normal or reserved in minor components. The second scenario reflects all historical earthquakes within 200 kilometers away from Aqaba if they occur again and may affect the Aqaba city as it is today. The 7.2 magnitude of the Gulf of Aqaba is intended to provide a calibration for the subsequent risk assessment. The next step was to make deterministic hazard assessment. Actually, for this study, the deterministic hazard assessment was evaluated using both intensity and ground motion parameters, PGA and SA, based on appropriate attenuation relationships as we developed it before. For both cases, the median 50 percentile value obtained from the used attenuation relationships was adopted. For this part of the deterministic seismic hazard method, the selected ground motion parameters of the analysis are peak ground acceleration PGA and a spectral acceleration SA at a period of 0.2, 0.3 seconds and 0.1 second using struct loss 1.5. This figure shows the deterministic PGA values for the 3 scenarios. Here I will show only the PGA values. 3 maps were prepared using GIS map for the 3 scenarios. If we take a look at the first scenario, we can see that the green color shows the values between 0.2 to 0.35. After that, 0.35 to 0.4 inventories. The inventories of the built environment were studied broadly in the following categories. We studied the building, the transportation system, water system, and sanitary system. This map shows a CISA zone. It is the same, it's Aqaba zone. According to the available maps, Aqaba is divided in 74 zones, but they are not completely named. However, to make our task easier, we assign names for those unnamed zones. We use a data from the Department of Statistics, DOS, and we divide each zone into blocks, into equal blocks. The block is defined as a group of buildings forming a locality or a part of it, which clear man-made boundaries such as paved or unpaved streets, lanes, passages, electricity posts, telephone posts, anyway, or natural boundaries such as mountains, rivers, and valleys are easily identified on the ground. A GIS map of 318 statistical blocks in an ArcGIS shape profile format was provided by the DOS and then edited for the accuracy of the boundaries between these blocks. In Jordan, we have a special type of buildings. So according to what we have, we divided the building type into seven groups. After that, we divided it according to number of stories into 3 groups. And the third step was the date of the construction. We divided it according to the year 1990.
Next.
Because in this year, the contractors and the engineers are start to applying the Jordanian building code. So anything built before 1990, we didn't include it in this study. We only include the buildings included built after 1990. This table shows the count of the building classes index. We call it BIJK identifier. We establish an arrangement or classes for the building types according to building type, number of stories, age of the building, and for each type we have the number of the buildings. So the total number of the buildings in the Aqaba city was 12,125. Regarding population and demographic data, this table shows also the same classes, but for this time in terms of the population and the number of people in each block. And finally, for the risk assessment for the three scenarios proposed before, we can see for each scenario the number of damages in the buildings. It's slight damage, moderate damage, extensive damage, complete damage, or the total number of damages buildings, and also the total number of buildings in the district in comparison to that. For example, for the first scenario, the damaged buildings are about 6,000 in comparison to the total number is 12,000, which is almost half of it. For the second scenario, it was 4,000, and for the third scenario, it was much less, about 200. This map shows, as an example, the completely damaged building distribution for all classes for the first scenario. We can see how many buildings will be destroyed according to the first scenario in each block of Aqaba city. This is for the second scenario also, and this map for the third scenario. After that, we came to the casualty estimation for earthquake scenarios, the number of people that may affect by these scenarios. For the first one, we classify for each scenario 4 severity levels, for 1, 2, 3, 4. For example, for the first scenario, and severity number 4, we have about 600 people. For the second scenario, we have about 300 people, and for the third scenario, we have only 4 people. Sorry? Oh, okay, thank you. Okay. We came to the conclusion that seismic hazard is technically restricted to the behavior of the ground apart from any effect on the building environment. The basic methodology on hazard analysis is comprised of source modeling, wave attenuation, and local ground amplification. This is commonly evaluated in terms of probabilistic and deterministic assessment approaches. Seismic risk assessment involves the investigation of urban exposure to existing seismic hazard, and Aqaba fault system is recognized as the main seismic source within the region, which runs through the offshore-onshore boundary of the Northern Gulf region across the city. And thank you.
You have presented basically seismic microzonation. You have presented basically the seismic microzonation of Aqaba city.
Yes.
Okay.
Yes.
And you have considered all the historic data,
Yes,
faults,
yes.
The soil parameters,
Yes.
shear wave velocities,
Yes.
and then you have worked out, and then you have taken
Three scenarios.
three scenarios.
See the elements of this.
Yeah, and then the compared to the total number of buildings,
Yes.
it is about half. In scenario 1, it is
About
50% of the
Yes.
houses taken damage. But you didn't talk about the deaths, about deaths, number of casualties.
Yes, because you told me to finish. It's available already. Number of, this is for shelters. These are according to casualties, number of people. It's in general.
How many?
In general, according to each scenario.
Okay.
I have a question on this.
Yeah.
continue.
Like a severity 1, 2, 3, 4.
Yes.
So, and what do you mean by total casualties? So, the total casualty will depend upon the, it will be restricted to only one scenario, because all 4 scenarios cannot happen at the same time.
This severity levels is according to HESAS 99. So there is a certain classification for each scenario. And gives you the number of people that may have hazard of maybe injury or death or anything else. So it's according to HESAS 99.
So this is very, very common issue. See, this is the photograph of part of Aizawl. No drainage channel and no rainwater collecting system. Rainwater harvesting system is very poor. And improper domestic wastewater disposal. In every house we are using water, and if the domestic wastewater was not disposed properly, then it results into a disaster. See, this drainage pipe, if it is extended, if it is extended up to here, then it doesn't culminate into disasters. But it is only up to this. It is only up to this. Thereby, it has to, it makes this part of the soil so saturated, more heavier, then it tends to flow down. Then sometimes we have water leakages from service like supply water pipe, sewerage system. When the water overflows those channels, it ultimately leads to landslide. See, we have a very serious landslide problem in 2013, 11th May. This building was collapsed. This belongs to State PWD office. Then there is no drain channel. There is no proper rainwater harvesting system. It was constructed in a very hill slope, 4 or 5 stories, more heavier. Then it flows down. It takes, it results into around 15 houses. It takes down, flows down. You can say that it is human-induced, anthropogenic. Conclusion. Now, unplanned development and construction activities create a probable danger for slope failures in around the city. Developmental activities like construction of building, road cuttings, embankment, cut and fill structures, it disturbs the natural slope. And as I have said, water is the primary triggering factors, And, Aizawl Municipal Council, which started 5 years ago only, put forward a draft site development and slope modification regulations 2014, which shall apply for the purpose of stringent control of all aspects of site development. If it is, strictly enforced and strictly monitored, we hope that this kind of landslide will be reduced. Awareness level of the people's capacity building of elected representatives, various government officials has to be, upgraded. And lastly, we bear in mind that to prevent and mitigate the incidence of landslide, it would be logical to take steps which would counter the effects of factors responsible for landslide occurrence. Thank you, Mr.
Mr. Chinko, you have presented very nicely, presenting the case studies for many landslides which occurred in Aizawl. Drainage is the most important part, but there is an earthquake triggered problem is also there. This is rain triggered actually, or moisture triggered.
So we are in
These are the
seasons
two
of
main factors.
if earthquake would have been happens there, then there will be more.
Yes, that's
more
what I'm
landslide.
going to say. The buildings you showed,
Yes.
one top over other,
Yes.
and it will have cascading effect,
Yes.
and then you will have a miserable time actually.
Yeah.
I think some corrective action must be taken, otherwise
Yes. Now we are trying to strengthen this district disaster management authority, and even the district disaster management authority ordered that some building has to be demolished due to their vulnerability.
For proportion in water. Even these things have been tested at the Imaging Center. Then we looked at the pedal boat, where you have a twin-hull boat system with a very low powered. See, these
water. It can penetrate, it can go on a very high speed.
about 36 kilometer. But then there are with car engine converted airboats, converted for air propulsion. They can go to the speed of 90 kilometers per hour. Yeah, not hovercraft. This is still an airboat, air-propelled boat. But then you have very powerful engines converted for air propulsion. So the weight of the engine is never a problem. One can always have a buoyancy compensated for that. So this system here, I am calling it as a boat that is unsinkable, uncapsizable. Fully filled with water, still it floats. So I think such systems in large numbers, we should be able to employ. The local bodies can employ it. The boat as such, the fishermen should be used during disaster. They are people who can really do a lot of things. And for transportation across the river, we can have a water auto concept, I'm calling it this. It can even be solar powered. Nowadays, going across the stream with the solar power is not a problem. One can have the power matching for that. So application inland water is always there. So retrofitting, the innovation we have tested in many places. Recently, across the stream in Oganekal, we could test it. So we augmented the buoyancy and put the outrigger. And with 20 people, mass transportation, the DSA asked already there. So basically, it's a catamaran concept, streamlining and positioning a motor. And we tested it for the the ability to turn left and right. We had an Indian Navy Commodore helping us in the design process. So we have manifolded 4 coracles together. And in the sense, this is a system that we should be having for cleansing Ganga. Because you can always take the load. The corporation should be using such a system. It's easy to use. And if you can manifold it in several distance, you can have bridges to cross the river. If we worry about standards in disaster situation, I mean, even otherwise also, the buoyancy capacity is so high, and you can dismantle it anytime you can go. But if you ask for the regulation for such a thing, it may not exist. But it's practical and very safe. Such floating bridges are available. They exist in developed countries. I mentioned that properly engineering a coracle is very important. So we have the bamboo mat board. We could get an inverted dome structure as a product. This can be scaled up to a level that states, governments can use it, fishermen can use it. In fact, Karnataka fishery departments, they have floated a big tender for such a product. But unfortunately, scale up is not ready at the time. Even now, scaling up is a big issue. Scaling, yeah, industrial. But we can reproduce it in any number at the laboratory level. So it's a important thing is the biosource material, cost we can match. So even during disaster, I understand that NDRF uses only aluminum boards. They never use even fiberglass boards. So rigid the regulations, that reaches. I mean, there are many boards one can supply, maybe. Networking institutions are the lessons learned. It's very useful. We spent very less in the project. And this is a field trial activity at Kollala village. When Krishna was in spade, we could go against the current. For monitoring, it could take about 4 people, buoyancy capacity. So interaction with the state government is KSNDMC and fishery department. This is in the recent, just as last month we could go to a spot where there are falls, accidents have happened. A family of 5 died, and they took a total review of the whole the boating sequence. We could say that this vessel will never topple, never capsize. So at least the fire station officers or disaster monitoring cells there could use it to go against the current in any eventuality. So we could do that. So airports, multi-ton vehicles will have to be introduced. Government of Botswana has done it recently. Deployed for anticipated Kashmir-like situation too. And it should be in a condition where it's maintained, kept ready. We focus our attention on improvising traditional, because there's nothing that you need to teach people. The improvised vessels, the traditional vessels, anybody can handle. Fishermen can easily handle it. All you need to is retrofit. The rim of a boat, the clerical boat is very strong, so it can be retrofitted. Government needs to have no reason for not applying these easy-to-use vessels when situation arises. Future transport system to seriously consider land-water capability in any eventuality. Disaster must be pursued as if it were at war. A lot of equipment are required. To save and sustain is very difficult. We should contrast with war. We are at war with nature when disaster happens. So science and technology intervention, deployment of land, water, vehicle system. We should be in totality, we should consider all the systems that is at our disposal. Can improve the situation a lot given the political will and the administrative. That's what I'm doing. Yeah. I would like to show some videos, please just. So I would like to acknowledge our director, our aides who supported the program, former directors, engineering chiefs of various integrated defense headquarters, director of Dr. Prakash, case in DMC, Ramakrishna, joint director, fisheries department. So all of them given very good support during field trials. Jnana Sekhan, chief secretary, Tamil Nadu government recently wanted an appraisal on our field trial. All these things became possible because one MSME was involved. It was showing extra interest. Just for, I mean, we're still not getting paid in any case. So my team supported. I just would like to play some of the videos just a second to get the appreciation of this. So this is Krishna in spade. The 4-seater, motorized with outrigger, fiber board, is able to go against. No, it will never cap, sorry. So there's fundamentally there is a feedback mechanism. The buoyancy correction is always there. The fiber board costs about 30,000, outriggers maybe 10, and motor costs about 60,000. So in 1 lakh you get a system, total system, I would say.
Normal boat costs 30,000?
No, normal boat would be very expensive, more than 2 lakhs, 3 lakhs. It's like owning a vehicle system, very expensive. How is it? Okay. Oh no, not really. It's only it will skim on the water. There's no propulsion system in water. Normally, boat has a propulsion in water. The outboard motor or inboard motor. Here, it's land. It's go in land. I will show that. It is if you mount the thing on a chassis with the wheels, you can go in land and move aboard. You can go into water also. 6 people. Oh, this is the chassis arrangement. Forget about the buoyancy aspect. The air propulsion can move in land. It goes same. Yeah. It goes about 30 kilometers per hour. Chassis, yeah. With the wheels and controls. Everything is brought to the front. With the push-pull mechanism, the air deflection turns left and right in water. Otherwise, we have a steering.
What is the cost of this?
Aero engine is the main thing here. The cost is more.
The most of the fishermen, all their ships are saying, maybe the boats are going because of the wavelength, right?
Yeah.
So if you invented or if you done something project which is very easy to move that, because fishermen is very hardly to get into the offshore. So because they have to like use bamboos or something to into the safest area. So if you done some kind of picker to carry that to the safest place. So there are a lot of
Yes, we are planning for a field trial in Kanyakumari.
really thank you, sir. Yeah, good,
So
good.
But this
Sir.
is capsize free, so you
Yeah.
can go anywhere.
Anywhere.
Yeah, that's
exactly.
right.
So the idea is to avoid the barrier of water.
Mm.
So
Yes, sir.
if you go to a fisherman,
Mm.
you will never be afraid of water.
Mm.
That's
Yeah.
something that we have to appreciate.
Yes, sir.
So, but then this enhances the ability.
Mm.
So once you are in the boat, as long as you are in the boat, you are very safe. The distance between the boat and the water, no, to you is only few inches, but you don't have to be scared about anything.
Okay, but this the fishermen boats need to be carried to the land area.
It is possible.
Yeah.
Yeah.
So that is actually the major requirement for the fishermen,
Yes.
because when there is any tsunami or any cyclone, or because they are giving a warnings, but they are not unable to move because to the longest areas. So using tractors or something and a carry picker like transport that boat into the safest area. So it's very easy to, because this concept indirectly uses.
You can apply.
Yeah, you can apply for that. That's my idea. So
Yeah.
I hope.
So you can build once you
Yeah,
see
you
it
have.
now.
So if you done this in a large scale, so every city and every
Yeah.
area it is 100%.
Water can never be a barrier.
Yeah, yeah.
And this is a system that we need
Yeah,
to have.
really good, sir.
Ah,
Right. Thank you.
okay. So if I have to do any trials in Visakhapatnam or in Andhra Pradesh, I'm willing to do that.
So definitely we should coordinate.
Yeah, please.
Because I am from Visakhapatnam.
Okay. We can, as you said, we can offload because the capacity is about 110. Yeah, right. We can do that.
I can
Chennai is leading this kind of.
Yes, but when we did the trials in Ogunekal, the collector, I stayed there for 2 days, did a very difficult field trial because nothing to eat, it's in a sand dune, we were kept there, and the collector did not come for 2 days. And when I was packing and with the proper relief, I was returning, and I got a message that collector wants me back. And then he said, minister is coming, please bring the items back. But it's all giant systems. Loading, unloading is a big problem. Not much funding. Still the state government committed for payment is still not done. They want a lot of reports. They have their own problems. I understand that.
But you mean I may support some line stuff because I'm
Yeah, NGOs can come forward.
Yeah, we are already done a good job for fishermen, nearly 100 families, so we considered a large step. So it's very right place to.
Yeah.
That
For me, yes.
session is very productive.
Yes,
Okay.
really, I appreciate this.
Yeah. Thank you.
Okay, thank you.
Please put it forward to when we have a panel meeting, that these are the products of the
Yeah, but I
national agency.
will not be there tomorrow.
Oh, I see. Maybe you can give it something in writing.
Yeah.
Okay. What is wanted is one fisherman, one boat. That is never the situation. These fishermen communities are kept in a lower thing all the time. they made dependent on some facility or the other. 5,000 rupees cannot be given to them to make a boat. It is not done actually. So, but these kind of innovation will actually help them a lot and for scale up. So 5 lakh into 5 states, or so much. It's like a mobile, you know.
Instead of giving the chain,
Yeah.
is giving the mobile for every.
Ola company is interested, as I heard. Ola is trying to hire boats.
Okay.
Maybe yeah, it's useful there. Yeah.
And moderate support. All top levels at work, and they mobilize every team members. This is the treatment in the secondary tertiary care hospital nearby area. Medicine provided to people for the chronic ailments also, and to increase mobility of fracture cases, crutches were also provided. These are base camps where treatment were provided. Now rescue and relief work, 7,020 running meter debris removed, 2,920 of mainline and 4,100 of sublane were cleared. These are the items we have distributed. We can say that corporate can support to the post-disaster management area by the awareness and training, by conducting mock drills. In every industry, we conducted 3 levels of mock drills. Level 1, level 2 and level 3. Level 1 is for the limited to the plant area of that sub-plant area. Level 2 is the entire complex. Level 3, when it's beyond the complex. So we involve government machinery also. Introduction of technology and innovative approaches, logistic support, man, machine and material, flexibility, speed and implementation, capacity building of the workers and local communities, and success factor of the ANJAR, valid our preparedness and philosophy of the company.
Mic sound Babu.
It was the longest 45 seconds. A story of hope, of starting anew. Thousands died in the Gujarat earthquake. One company said, the humans
वो डैश का उसके बाद कौन सा वो माइक यहाँ पे लैपटॉप के पास
It's a company that belongs to Gujarat.
As a responsible corporate citizen, Reliance took the lead. One phone call set the action moving. Resources were mobilized, not only from all our units in Gujarat, but our entire infrastructure in India.
Reliance knew that the need of the hour was coordinated planning and action. The first thing it did was set up a control room in Jamnagar. A tent in Anjar served as a base camp with a satellite telephone. With communication lines established, rescue and relief work could be coordinated with greater speed and efficiency. Operation Anjar went into action on a war footing.
Same Reliance team had done rescue and relief operations several times before. So we quickly got into the action, divided the whole city into 4